Folks, my name is Cy Venom, and I'm a developer advocate with AWS. Today, we're doing a session on CDK. Thank you so much for joining me. Could you quickly introduce yourself?
Hey, Sai, thank you for having me here. It's a pleasure. My name is Ilamaran Shanmugam. I go by Ila. I'm a senior cloud architect with the AWS Professional Services.
Awesome. Folks, I'm going to be looking at my laptop once in a while here. Here's where I've got the kind of stream deck, and I get to look at questions, comments in YouTube, LinkedIn, or Twitch, wherever you might be watching this. Now, Ila, we've got a pretty exciting talk today, right? We're going to be talking about CDK and how you can use it to manage multi-region Kubernetes deployments. So, Ila, very quickly, can you talk about what you do for AWS and why this is a topic that's maybe a little bit close to heart?
Absolutely. Thank you. I mean, it's a great topic, as you said, and it's a very important talk of the town topic. So I help public sector customers to migrate and modernize their workloads to AWS. I'm a container SME, I'm an observability SME, and I love to automate everything. And that's the most important context of this discussion. And I'm a huge fan of CDK, right? And I have seen so many public sector customers try to use CDK as an approach to deploy their infrastructure. So that's why this is a very important topic of discussion today.
Awesome. Very cool. So very quickly, before we jump into this, I think we need to understand what exactly is CDK and where it lies in, the ecosystem of infrastructure as code solutions. So CDK standing for Cloud Development Kit, which is basically a way for you to work with cloud resources on AWS using programmatic languages. But the other thing we mentioned here, infrastructure as code, I think is at the root of it all. Now, in your own words, Ila, how would you describe infrastructure as code?
Yeah, definitely, Sai. So infrastructure as a code is basically the de facto standard for you to create a repeatable infrastructure, right? So let's say you want to create identical stacks, or you want to create multi-region workloads, right? Let's say you wanted to create infrastructure in multiple different regions with identical stacks. Infrastructure as a code is a de facto standard. And talking about infrastructure as a code, right, there are quite a few options customers have, like starting from CloudFormation to Terraform to using Pulumi and Cloud Development Kit, right? So since we're talking about Cloud Development Kit, right, the key advantage of Cloud Development Kit is it's polyglot, right? Meaning you can use any of your favorite languages, and still you can build cloud infrastructure components like VPC, subnets, EKS clusters, and then Kubernetes components like ingress, services, pods, all using Cloud Development Kit. So that's a huge advantage when you talk about infrastructure as a code, specifically CDK.
All right. So, very quickly, I think before we jump into the sketching portion of our presentation today, I want to understand, where does CDK lie in comparison to some of the other infrastructure as code tooling out there? I think people think about Terraform quite often, as well as Crossplane. There's more GitOps-based approaches to managing infrastructure using code. Where does CDK lie amongst these?
Absolutely. That's a great question, Sai, to start with, right? So we talked about polyglot, we talked about imperative, but the biggest aspect with CDK is the unified code-based approach, right? So with CDK, you can write your cloud infrastructure, like I said, you can write your Kubernetes resources with CDK. And the most important aspect with CDK versus using Terraform and CloudFormation is you can also keep your application code in the same repo as your cloud infrastructure and your Kubernetes components, right? Which means you're going to have a single source of truth for infrastructure and your application code. That unification is going to really help you to operate at scale.
Okay, so I want to write out some of these kind of advantages. Now, one thing that I think you had mentioned here right off the bat was that it kind of allows you to unify kind of the different things that you might be deploying, right? So as an operations engineer, even as a developer, you might be responsible for the underlying infrastructure. And then what's running on top of it. So maybe things like Kubernetes clusters, which is going to be a big focus of our talk today. And then within those clusters, you have applications themselves. And so there can be a lot of cognitive overload if you're managing, all of those different resources with different tools and technologies. So notably, I think one of the first key advantages of CDK, and you mentioned this, and I think in your upcoming blog, you talk about this in depth as well, is the fact that it's kind of this unification layer.
Exactly. Unification is a key advantage with CDK.
All right. In addition, I think one of the things that, because unification is something that applies for, I think, most infrastructure as code tools, right? You're really leveraging tools that allow you to combine, managing multiple layers of your stack. That being said, I know, for example, Terraform is really geared towards managing the infrastructure layer as opposed to kind of some of the other layers, right? So could you talk a little bit about that and how CDK might be a little different than something like Terraform?
Yeah, absolutely. I mean, maybe I can talk about this with an example use case, right? Let's say you take an individual independent software vendor, right, who's developed a product which cannot be multi-tenant, right? It has to be single tenant per customer or per tenant, right? Or let's talk about a customer, right, who has built a product in AWS with Amazon EKS, right? The product is very popular, so he's trying to scale his product, right? He wants to geographically improve the footprint. With CDK, let's say you want to improve the footprint of your infrastructure. All you have to do here is just add few lines of code to your CDK project, and then you're going to get an identical stack, right? Identical stack for infrastructure. Plus, you can also use the same components that you use to deploy to one region to another region, which means the concept of unification of not just the infrastructure, but your workload components, your Kubernetes resources, and your, go ahead, please.
No, definitely. I think that's spot on. I think that's exactly where I think CDK and use cases around CDK, that particular example you laid out, I think you talk about more depth in your blog. I want to talk about that today, and hopefully we get to sketch all of that out. And I'm really excited to get to that bit. But I do want to loop you back to one of the other kind of advantages that you were kind of going through there. So specifically with CDK, you can use a number of different programming languages, right? To work with.
That's right. Yeah, polyglot, right? Obviously, you can use TypeScript, you can use Java. If your favorite programming language is Python, yes, CDK is in business, right? Because you don't need to learn YAML-based languages and stuff like that. Use your programming language which you're favorite about and start building cloud infrastructure.
Yes, exactly. And I think that's probably the most significant advantage here, is that for teams that have specific skills, they get to reuse those skills when working in these environments. You don't have to necessarily pick up a new set of skills for managing the infrastructure versus managing your application stack. Say has really strong JavaScript, TypeScript skills. They can continue to use that to manage the infrastructure as well. I think that's a pretty critical advantage. The last one I'll mention here, I talk about infrastructure as code and a lot of different infrastructure as code technologies in some of my Lightboard videos, including Terraform. And in those videos, I talk about how one of the critical things with a lot of those is whether they're imperative or declarative. And I think it makes a big difference for when you're managing infrastructure, because imperative, I like to think of it like you're getting in your car, in your garage, you put the GPS on, and you follow every single step it takes to get to the final destination. And if you mess up, you need to backtrack. You need to make corrective actions to get back on the right track and make it to your destination. And so I would say that's kind of an imperative approach. A declarative approach is when you just state the final state that you'd like, and the stack, the technology you're using takes care of the steps for you. So this is like calling a taxi or an Uber or a Lyft, where you tell them the final destination and it takes you there. And CDK specifically is imperative.
Imperative.
A lot of videos I've talked about how I technically, for the most part, I prefer declarative. Can you talk about a little bit about the way customers use CDK and maybe the kind of imperative nature of it?
Yeah, definitely. The key advantage and the key fundamental aspect of CDK is imperative. It's very direct, and you can go ahead directly with this, right? So one thing I can emphasize with the CDK imperative approach is why it is going to help the customer is the day-to operations aspect, right? With imperative in nature, with polyglot in nature, most importantly imperative, The aspect of day two operations comes into picture, how you upgrade your clusters, how you upgrade your applications, right? Being imperative is going to be a biggest advantage with CDK to achieve those day two operations aspect.
Okay. And I think it's a matter of preference as well. I think for some folks, they want to have that fine-tuned control over the way that their applications are structured and deployed. For example, I know that with Terraform, if you want to structure the order in which things are deployed, you have to use sometimes it's a little convoluted, using implicit dependencies. Or for example, if you want to deploy the exact same thing multiple times, it's kind of hard to do like a for loop in a declarative language, whereas an imperative, it's very straightforward. It's
straightforward,
top to bottom. So there's I think situations where one or the other might be beneficial for the user. So really quickly, we're getting a lot of comments asking how is he doing that, and how is it working, and where's the couch? Well, I'll have to get a couch for a future episode, but very quickly, folks, the light board, it's basically a glass between myself and the camera. I've got Ela on webcam joining me here, and he's going to be walking me through how to sketch things out. If you catch me looking down here in the corners, because my laptop's here, I'm looking at the comments that you folks are posting. If you have any questions while we're going through this, please don't hesitate to ask. If we don't have a chance to ask or answer your question, Ela will leave his information at the end if you want to get in touch with him. And of course, you can always get in touch with me on LinkedIn or Twitter. I'll be sharing those details as well. We are streaming this on twitch.tv/AWS, and it's hosted by our channel, Containers from the Couch on YouTube. But without further ado, let's get into it. Ela, I'm excited for kind of the architecture piece of our demo today. And yes, daily push on Twitch. You got it right, by the way. The mirror, the glass itself is mirrored so that I'm not actually writing backwards. I'm not that talented. It's kind of like a trick to make it look like I'm writing backwards, so you folks can see what I'm seeing.
And that's size magic. So.
All right. So very quickly, I like to, when I start sketching these things out, I like to think about user personas. And today I want to think about a dev persona and an ops persona. And when we set up CDK to do multi-region Kubernetes, again, that's what your blog is about, I want to start with ops, because at the end of the day, ops are doing the heavy lifting. So developers, for better or worse, can focus on developing applications. Right, exactly. So let's lay this out here. And I'll say that I've got a operations engineer, myself enough space here. And this ops engineer, they want to set up an environment where the devs can come in and just do what they like to do, git push, and then have pipelines kicked off so they can deploy into Kubernetes. And we'll also add a detail of multi-region Kubernetes before the end of the call. But we'll start with just how do we get the environment set up in the first place? All right, so we've got an ops engineer. What's the first thing that they need to do to start working with CDK?
The first thing they want to start using is there is something called CDK Bootstrap in the specific region they wanted to deploy their CDK code. So that's the first step they can do to be prepared to run CDK script.
Okay, so let me write out some of the commands that we'll be using today. I'll make sure that I'm not cutting it off here. So CDK Bootstrap. But before they run that, they need to create some configuration, right? They can't just run CDK Bootstrap?
No, they can directly run CDK Bootstrap because Bootstrap is outside of their code base, like CDK project. So they can just do a CDK Bootstrap for that particular region and that account. So that's the first step. But moving forward, right, the first thing in the ops engineer after the Bootstrap is going to do is create something called CDK project. In his CDK project, he's going to create different stacks that makes his environment, right? To start with an infrastructure stack, like a cluster stack, then you can do a container stack, and then you can do a CI/CD stack. So let's start with the cluster stack.
Okay, sounds good. So the cluster stack, I'm assuming as the name implies, we're using this to create a cluster, a Kubernetes cluster, right?
That is correct. the cluster stack is going to create the VPCs and subnets and all the important components that is required to create the cluster, and then it's going to create the EKS cluster.
Okay, so very quickly, just so I have it right, let's call these stacks. And I'm going to write out the stacks one by one here. And the first stack you said is a cluster stack. So we mentioned a few things here. We're going to need a VPC. You mentioned subnets.
That's right.
And let's say the cluster itself. So we'll call that EKS for Elastic Kubernetes Service. And all of this exists in the first stack.
Yep.
All right. We're going to just call it cluster. Let's just call it cluster.
Yep. Cluster. Fine. Fair enough.
All right. And so that's the first stack. What else do we got here? You mentioned, sorry, go ahead.
The next stack is going to be the container stack. The container stack is going to hold all the day two operational tools that you wanted to have in your cluster. Like if you want to have Prometheus, if you wanted to have RBAC rules, if you wanted to have GitOps like Argo CD, all those things goes into the container stack.
Okay, so I'm writing out a container stack here. Now, just to be clear here, the ops engineer, they're not deploying any applications. They don't care about the product, the functionality. They're deploying things into the cluster that the user may want to use. Is that right?
Exactly. So, that's the part. Yeah.
Yeah. Let's walk through what some of those things might be. So you mentioned Prometheus, Grafana. So maybe we can just say observability. And
observability tools, and also you can call GitOps tools like Argo CD. Maybe call it as GitOps.
Okay. So we'll call that GitOps. Here, let's use a different color.
Yeah. I like the green color.
Anything else? What else will a user potentially need? The developer, what will they potentially need in their Kubernetes environment?
Yeah, RBAC, right? Role-based access controls. You also need RBAC policy, so you can add RBAC.
Of course, we don't want the developers to have permission to namespaces that that they're not working within. So, for example, if we want a cluster where multiple devs are able to develop apps, we want to give them, following the principle of least privilege, exactly the permissions that they need. So let me draw that piece out.
And most importantly, it is not very limited to this. You can add all your day two stuff here, but we are just limiting to few things, just for example. Yep.
All right. Now, if I remember right, there's one more stack here, right, from your blog?
It's called CI/CD stack.
CI/CD. Again, I'm guessing I know what this means, but this is going to be the kind of the CI/CD tools that the developer uses to deploy applications and code into the cluster we create.
You got it. Yes, it is going to be the CI/CD tools that we're going to use. In this context, we are opinionatedly using our AWS code suites like CodeBuild, Code Pipeline, Code Deploy. We are going to use that to deploy our infrastructure. Deploy our application for the developer.
Got it. I did get a comment that I should write a little bigger, so I'm going to try my best here. So starting here, I'll start writing bigger. But so you mentioned code commit. We've got code pipeline.
And code build. That's it.
And code build. Do they do what they sound like they do?
Yes, they do.
Very, very simply, I'm guessing code commit is where code is stored. Pipeline is kind of the receiving triggers. It's kind of the mastermind. And the code build is going to be where the builds are actually running themselves.
Yep, you got it. We'll zoom in, Sai, but at this point, yep, you got it.
Okay. So right now, all we're doing is configuring the different things that we'll need to deploy into the environment itself. But so far, all of this is local, right? It's in the ops engineer's local machine. They're just writing this out on their laptop.
Yep, he is writing it all on his laptop. But at some point, he will also be pushing into the code repo, the same repo which we created for code commit. But that's out of the business here. But yes, he's going to all write it in his local, and then he's going to go into the next steps, which is like running a couple of other commands before he can deploy this. So if you want to talk about the next command side, it's basically called CDK list.
CDK list. All right, what's this one going to let us do?
Basically, you have created 3 stacks here. So let's say you wanted to know what are the different stacks in your CDK project, right? You just do a CDK list. The output is going to be cluster stack, container stack, and CI/CD stack. So it's a list of all the stacks in your CDK project.
Okay. So I'll basically see a view kind of like here, but in
Yep.
terminal CLI format. Okay. All right. What's next? So I see it. I've confirmed it. I think it looks good.
Okay. The next step is going to be using the command called CDK diff, where if you want to see what are the different AWS resources that is going to be created as part of this particular deployment, you can use a CDK diff. Just from an analogy standpoint, if you guys are using Terraform, you use Terraform plan often. So you can compare the Terraform plan with CDK diff. So it's going to show you all the resources that's going to be created as part of the stack deployments.
Okay, so in this step, is it actually calling APIs like AWS Cloud APIs with your authentication token and everything to validate what's going to be created?
No, it does not. So basically here, it's basically going to list you all the resources, right? Basically, it's going to transform your CDK script into resources from the transformation standpoint, and it's going to show you all the stacks that's going to be created as part of this process, all the resources. Yeah.
Right. So I'm trying to understand why it's called a diff then. Is it what is it diffing? Is it diffing what do you have locally and what's in the cloud, or what's the diff?
So basically diff, you are right. So basically what's going to happen is you're going to have 2 different states, right? Fundamentally, we are deploying it for the first time. So the difference is null, right? But if you're going to do it for the further occurrences, right, you're going to know what you have done already versus what's going to change. And that diff command is also going to show that for future occurrences of changes that you're going to deploy.
Got it. So this is critical. And I think it's an important part of not just CDK, but infrastructure as code as a whole, that day 2 operations, when the ops engineer comes back and says, hey, we have observability, GitOps, and RBAC, but now we want to deploy, we got some examples in the chat, auto scaling or ingress controllers or CSIs, container storage interfaces. So for that day 2, when the ops engineer comes back and does its CDK diff, let's say they've already deployed all of this, it'll only deploy the piece that they need, right? Is that fair?
Yep. Yes, it is definitely going to be incremental, only the piece they need. That's a huge advantage of this approach.
Yeah, I think that's a critical thing that people are looking for, many ops engineers are looking for when choosing these types of technologies. But okay, I'm convinced I think it was kind of a trick question that I gave you. It is the first time that we're running this command, so of course it's going to come back with a full list of things it's going to deploy. So what's next?
Okay, the next is the magical command, right? CDK deploy. And there are 2 variants of this command. Let's say you wanted to run 1 stack at a time. You just say CDK space deploy space the stack name. Or if you want to deploy all the stacks together, you just say CDK space deploy within double quotes start.
Okay, so we can either do stack or deploy them all with double quoted star. Got it.
Yes.
So that makes sense. That's I'd say a pretty good 1, 2, 3, 4 set of commands to run. I think now is probably a good idea to draw some of this out. By the way, we did get a couple of questions in the chat. And yeah, okay. So one of the questions was Terraform gives me the same, and this is in reference to the CDK diff command. Eli, I think you had mentioned that the Terraform plan is very similar to the CDK diff. Is that right?
Yes, it is. It is.
Okay. Yeah, I think that's all the questions we've got for now that are at least relevant. So let's keep it moving. We've got the stacks defined. Let's do a deploy. Let's see what happens here. Now, will the operations engineer run this on their local machine generally?
Yes, they will run this on their local machine. But if they want to also, let's say they wanted to do a different approach where they want to use GitHub Actions and they wanted to deploy it through the GitHub Actions, that is also possible. But at this point, we are just doing it locally. so that it is going to create cloud formation stacks in the target AWS environment for each of these stacks. So that's the next step that happens after the deploy command.
So let me just write this out as CloudFormation. So when they run the Terraform, or sorry, not Terraform, but CDK deploy, it's going to create some CloudFormation.
CloudFormation stacks, yes.
Okay, next, I think that in turn is going to create the environment that we'd like, right?
Yeah, exactly. It's going to create the resources as per your definition of the CDK script.
Okay.
So basically, go ahead.
Right now, we've only configured one cluster stack, one container stack, and the CI/CD. So let's start with the cluster stack. Let's say that we're deploying into US East 1. So this is a VPC. And sketch out a little box for this guy. And then within there, we have our EKS cluster.
You got it, yes.
But this EKS cluster right now doesn't have any running workloads in it, but it may have some of the things we configured up here. So it's going to be configured with the RBAC rules. Oh, excuse me. Is that on my end?
I think so.
All right. Okay. Sorry about that. We're doing it live. So it's going to have the RBAC piece that we configured, maybe some observability tooling in here.
Prometheus and stuff.
Yeah. And maybe anything else that you had configured. But we're going to leave some space here because we want some space for the developer to come in and deploy their workloads, right?
Exactly.
Okay. So good. So far, so good. The ops engineer has set up the environment we need, and the developers should be happy. Let's take a look at it from their perspective of what they get to do here. And
let's do that,
Let me start on this side. I think it makes most sense. Make sure I'm not writing off the edge. And we're going to say we've got a dev here.
Yeah.
So what does the dev have? So very quickly, the dev has code, right? And this is code on their local machine. So let me draw.
Yeah, before we skim through what the dev is going to do, let's draw out what the CI/CD stack is going to do, right? Because you have deployed the cluster stack, the container stack. Now we have to deploy the CI/CD stack, which is done through the deploy command. Let's skim out what are the different components that's going to come in place for that stack.
Right. Because when we did the CDK deploy, we deployed all of these things. So let's at least sketch out what got deployed before the developer even comes in and tries to use it. Okay?
Exactly.
All right. So the first piece that we've got here, well, what do you think we should start with here out of the CI/CD stack?
I think you should start with the bigger box, calling it as code pipeline. Then the first component of the code pipeline is code commit. Then we should have a code build and then another code build. But the first component is a bigger box, a code pipeline.
Okay. So let me write that out just kind of broadly here.
Sure.
Code pipeline.
Yep, which is basically
let's have an imaginary box here. Let's say it's like right here. And I think the first component of code pipeline, so wherever the developer will be pushing code into, is code commit, right?
Exactly. Yes, it's the Git kind of a repo. You can use the same Git commands like git commit, git push. And once you do the git push, the code goes and sits into the code commit repo.
Okay. So I have the logo right there. I'm going to try to make it look as possible, like the official logo. All right. I think that's good enough for now. So right
that's
here,
awesome, Rob. That's awesome.
Thank you. Not so much an artist, but I try. Code commit. So that's one of the things that we deploy as part of this kind of stack. By the way, this code pipeline, is it locked to a specific AWS region? Is it deployed in a specific region?
That's a great question, Sai. You got it, right? We're going to have some great surprises in the next 10 to 15 minutes. But yes, code pipeline is going to be part of the US East 1 region.
Okay, let's write that out here. And so this is nice. So I'd expect things to work as expected, obviously, because it's the pipelines in US East 1, our clusters in US East 1, we're good. And like you mentioned, maybe we have some surprises later. Of course, title of this session is Multi-Region Kubernetes. And right now I only see one region, so I'm going to have to hold you through that. So we've got the code commit piece. What else do we draw out here?
Okay, code build. Go for a code build. And that's another challenging logo, but good luck.
Okay, let's do it. I think it's like a crane. So we've got one of these guys over here. And while I'm making my masterpiece here, maybe you can talk a little bit about what CodeBuild does.
Yeah, of course. So I'll start with code commit, right? So code commit is where you're going to check in your code. It's a Git kind of a repo. So once you're done with code commit check-in, right, code pipeline is going to monitor that. And under the hood, there is something called CloudWatch events. And that CloudWatch events is going to trigger code build. So code build is basically a continuous integration, highly available, continuous and managed continuous integration service, part of AWS code suites. So what this guy in this diagram is going to do is he's going to build the code that you have checked in, and he's going to create a Docker image. And that Docker image is going to be pushed into Amazon ECR, which is the Elastic Container Registry. So we are going to use ECR as a container repo for this particular sketch.
Okay, so ECR, let me kind of draw that out right here. And so here's where the container image that gets built here. So very quickly, let me walk this through. So the developer has code on their machine. They do a git push, right? So
yes,
let's talk about that. So they'll do a git push into the repo. That's in AWS. That triggers a CloudWatch event, which tells CodeBuild, which I have sketched out right here, to build that code into a Docker image and throw it into ECR.
Perfect, you got it.
Awesome. So that's the first step, but we still don't have running containers in the cluster. So what's next?
Okay, the next step is another code build step. The code build is basically going to deploy the, yeah, good luck with that. So code build is the service for Amazon EKS that is going to deploy the application into the Kubernetes cluster, EKS cluster we have created already.
Got it. So this is going to take this image that comes out of here. So instead of drawing code, I'm going to show it holding a container. There you go. So using the container from ECR, is it fair for me to draw an arrow from ECR to that container? Because it's pulling it.
Oh, yeah, it is definitely fair. Definitely fair. Yep.
Okay. So it's pulling ECR, the container image from the ECR, and then the code build will push that workload into the cluster. Is that right?
Yep, it is correct, 100%.
All right, awesome. So finally, we've gone from code on a local machine to running containers in a cluster. All right, very cool. Now, anything we're forgetting here? Any specific part of this that I think for the most part we have this sketched out end to end. The git push, the CloudWatch events that trigger the code build. Oh, I have a question. So once the build happens, is there any sort of approval step that we can insert here to deploy into a single region?
That's a great question. I want to reserve answering to that question when we build the second cluster, if you're okay with that.
Okay, then let me rephrase that then. What about right here? Is there an approval step that we can put in, like a PR process in code commit? So before we push to master and break prod, is there a step that we can insert here?
Absolutely. So you can follow the same Git continuous integration process that you follow in your organization. You can use the PR process where you can push it to a branch, and then you can have a lead guy who can just review the branch and then merge it to the master, and which can kick off the code commit process. Yes, absolutely. We should follow that process.
Okay, perfect. Very quickly, let's take a look at some of the comments. We've got some comments coming in. A lot of folks are interested in how we're doing this. Again, I'll quickly recap. So I'm not actually writing backwards. We have a glass kind of between me and the camera, and we're mirroring it. So no, I'm not that talented to draw all these things out backwards. But I think we're just following this really simple technique where we flip it. So I think some of you noticed my ring's on my wrong hand, the watch's on the wrong hand. But yeah, it's a simple trick that we use to be able to do these kinds of live whiteboarding sessions. Got another question. Are the Kubernetes manifests of the specific application in the repository? I'll let you answer this one, Ela.
Yes, it will be part of your code repository. Basically, if you keep the source in a source directory, it will be part of your code repo when you check in. And in your code build step, you'll be writing your script in the code build step to fetch from that directory to use the YAML in your second code build step to deploy to your Kubernetes cluster.
Very cool. We have another question in the chat, and I might be able to take this one. Asked where in the cycle is redundancy built in case there's a crash on a server. And so I think there's two phases where a crash could potentially occur. Maybe I'll take the first one, and Ela, you can handle the second one. But I think the first case is if the crash occurs in the Kubernetes cluster. And I think the second case is if a crash occurs somewhere in the pipeline that things are being deployed. So if there's a crash in the Kubernetes cluster, I think this is one of the biggest advantages of Kubernetes is that they're self-healing. So once a container specification, like a deployment or a pod or an ingress or whatever it might be, has been deployed into the cluster itself, the cluster is going to handle the health and the life cycle of those artifacts. So if there's a crash, container comes down, Kubernetes itself is going to be able to manage the health of it and bring it back up. But Ela, is it a concern for crashes in other parts of this? I know that we're using some managed services here. What do you think?
Yep. Yeah, so that's actually a great question, right? So in terms of code suites, right, as I was telling you before, the services like code commit, code build, and code pipeline is all managed service, right? It's basically the crashes with respect to high availability of the service or anything else, right? AWS is going to take care under the hood because it's a managed service. But typically, if there is a problem with respect to the script that you have written, right? Let's say you have not written, basically for code build steps, you need to write your own bash script, right? So let's say you've written an error in your script, right? Yes, it's going to throw an error. The code pipeline is going to stop in that step. So what you're going to do is go through the logs, find out what is the error, fix that particular piece of the script, and you can recheck in the code, and the process starts, and that fixes the problem, and the pipeline moves forward. So it's a typical CI/CD process where you fix the issue and move forward, kind of a deal.
Okay, very cool. And I think specifically different infrastructure as code languages have different approaches to handling errors. So CDK might have a different approach than Terraform. In fact, being imperative versus declarative, they're obviously going to have a lot of different considerations. For example, things like error handling in CDK. If things fail halfway through the execution, how are you handling it? Are you wiping everything out? Are you retrying? And I think these are the kinds of things you need to think about when using an imperative language for automation of infrastructure, right?
Yeah, and an important thing that I forgot to mention is when you're trying to do a CDK deploy command, to your point, Sai, right? When it's going to translate into a CloudFormation script. A CloudFormation script is going to deploy all the scripts, all the items in the stack in an order, right? It's going to follow its own order. Unless you have a dependency, it's going to deploy all the resources, right? Let's say if any of the resource is failing, right? It's going to follow the CloudFormation's paradigm of rolling back and deleting the stack and whatnot, right? It has a built-in failover mechanism when it comes to deploying the stack.
Perfect. Awesome. I think now we're here for the piece that you and I have been teasing out a little bit here. Again, we know that we're talking about multi-region here, but right now we've got everything in one region. It's all in US East 1. So how do we do multi-region? And I kind of know the answer to this, but I'll set you up either way. Do I need to recreate all of this, the pipeline, the stack, and everything to create another region with the exact same kind of infrastructure, containers, apps that was created for our first region?
I'm afraid yes. Oh, I was joking. No, it is not. So all you have to do here, Sai, is go to your CDK script, write like 3 to 4 lines of the code to repeat your infrastructure to create more stacks, and that's it, right? So basically, you do a repeatable aspect of cluster stack, repeatable two line code for container stack to create in the next region. Yeah, you got it.
So right now we just have one, cluster one. But what you're saying is with very little code, I can come in here and duplicate this stack.
Yes,
the cluster,
you are right.
The container stack. And now, voila, I have both cluster one and cluster two.
Yes. And one more thing is, from the regional standpoint, you have the Kubernetes cluster and the Kubernetes cluster day 2 operational components. But from code build standpoint, you don't need to create one more code pipeline, right? It's unnecessary, right? So what we are going to do is in the CI/CD stack, we're going to have 2 steps. One step is a code build step that is going to deploy to a newer region. The other step is a magical step, which we are going to talk about when you're going to draw the diagram.
Okay, perfect. So that's the critical thing. I think we're duplicating the cluster stack and the container stack because obviously we want 2 of those, but not the CI/CD stack because we're going to be able to reuse that. So the second I do that bit of code to duplicate the stack, I run through all of my commands again. I'm pretty sure I can skip the bootstrap one, right?
Yes, you can skip the bootstrap. You cannot skip the bootstrap. That's the magical aspect, right? Sorry about that. So since you're going into a newer region, you remember the definition of bootstrap I was talking about. Bootstrap has to be run in each and every region. So which means if you're going to use US West 2, you have to use CDK bootstrap the account number with the US West 2 to bootstrap the newer region.
Got it. So you said US West 2. So let's call it that. We'll draw another box here. And I think the magic of all of this was that this is really getting created without us having to duplicate really much of any work. We can reuse the same stacks, but just point them to a new region, right? So I'll probably have to go into the stacks and find specific things like subnet IDs, the VPC IDs, and the region that they're pointing to. But outside of that, we're reusing almost all of that code.
Not even that, Sai. What we are doing here is the APIs which creates new VPCs and new subnets, which means there is no manual code. You don't need to do any kind of changes in that regard. All you're doing is a 3-line code which repeats the infrastructure in US West 2.
Oh wow. Okay then. That's even easier than I thought then. But okay, so we've talked about the cluster and the container stack. What about for the dev? The ops life was easy, but for the dev to now push to a new region, the containers are right now only in US East 1. The ops engineer has duplicated everything but the code itself. How does the dev get workloads into the second cluster here?
So in here, there is no work for dev. Dev has nothing to do here because ops is doing the heavy lifting for him, right? So here, what's going to happen is, since we made some modifications to the CI/CD stack, that is going to introduce 2 more stages. I'm afraid if you don't have a room there, or maybe you can go a little bit up. I'm sorry about that. But we're going to add 2 stages to our CI/CD pipeline. One is an approval stage. The next one is going to be the code build stage. The approval stage is going to answer your question 20 minutes back, Sai, right? Can I have an approval stage before deployment? Yes, you can add an approval stage to code pipeline. The next stage is a code build stage that is going to deploy to the newer EKS cluster.
Okay, got it. So we're going to call this, that was the first code build. This is the second code build. And now we need a third one. And I'm going to make this a little bit easier on myself and draw a little mini. So this
Sorry about that.
No, this is great. It's a cute little crane here. And we're going to call this code build 3. And this is the one that's going to be deploying the containers here. So let me draw that out first, but I want to quickly understand the approval step and who's actually calling this. So let's say that I put the approval step right here. And so the approval comes in and then the build goes in. Who's calling the approval step? Is it the first code build here, that one that's actually getting the trigger for the event from the code itself?
No. So that's the code pipeline magic, right? Each and every stage code pipeline uses the concept of CloudWatch events under the hood, which is going to orchestrate each and every stage. So right after the code build 2 step, right, under the hood, it's going to use the CloudWatch events and it goes to the next step. So when you configure an email ID, so code build, the approval stage works in 2 ways, right? So basically what you can do is once the approval stage comes in, you are going to get an email. Whatever is the email that you're going to configure in the stage, that guy is going to get an email. Maybe he's the lead developer or he's the approver, he's the ops lead, right? So what he's going to do, he's going to go into the environment and he's going to approve that step manually in the code pipeline. And then it is going to click on the CB3 step, which is a code build 3 step to deploy to the new EKS cluster.
Got it. So these are kind of consecutive steps that are being kicked off. Mm-hmm. Can they happen synchronously if the developer wants them to synchronously go to all regions, or in this layout, how does that actually happen?
You can do synchronously, right? So the question you are asking is, can I deploy to 2 regions at the same time, right? Yeah. So there is something called parallel steps. So here you are having it as sequential aspect, right? Even in code build, there is a concept called parallel steps. So after the CB1 step, you can have CB2, CB3 parallelly, which means that as soon as the CB1 step is done, CB2 and CB3 can kick off parallelly, and it can deploy to both the clusters simultaneously.
Got it. So I could, effectively have it where code build 1 kicks off kind of both code build 2 and code build 3 at the same time, and then pushes the containers in. And I guess, the sky's the limit. I could have as many regions here as I really want, right?
Yep, that's why I told you, right, for an ISP setup, like an independent software vendor, he wants to scale with multiple clusters. This is a great approach. You can multiply the stacks to any number of new tenants.
And I think critically, we're not multiplying the CI/CD piece. We'll need to create individual stacks every time we want to create more clusters or the container workloads inside the clusters, but we can use the same kind of code commit, code pipeline, code build, a CI/CD stack for the deployment of containers themselves. So I love that, but I do want to understand, right in the beginning, of course, we're both AWS, and we're talking about AWS technologies for the CI/CD. What if I wanted to take all this out and plug in a different CI/CD set of tooling, whether I'm using something kind of simple like Jenkins and Travis, or maybe a combination of Argo CD and Flux, or a lot of different options here. Could I do that as well? Can you talk about maybe opting out of using some of these AWS solutions and using some other tooling?
Absolutely. You can, for example, you can use Jenkins, right? You can build your own Jenkins pipeline, and you can use your own code commit repo. Let's say you want to use GitHub as your code commit repo. We can go for it. With the GitHub, you can have GitHub orchestrating a Jenkins pipeline. With the Jenkins pipeline, you can run those build step and deploy step directly, assuming the cluster context onto the Kubernetes cluster. That is definitely possible. Only thing that is going to be a caveat or a disadvantage aspect is the unification piece. The number one advantage that you've written in the top right? The unification piece is what we are going to miss, right? Unifying the code, Kubernetes clusters, and the application code in a single cluster is what we are going to miss. But there is absolutely no problem. You do it separately, and there is not going to be any because this is not scalable architecture, and you can do it that way, no problem.
Yeah, and maybe let's quickly talk about using some of these capabilities. I mean, code commit, code build, we offer SLAs on those. Those are kind of managed services. So to some extent, you can just expect that they'll work, right? As an end user, you don't have to worry about scaling them out. Whether you're using this to deploy 1 commit a day or 1,000 commits per day, you can really expect that backend to scale to your needs, right?
Absolutely. That's the huge advantage of the managed services aspect. You don't need to worry about the underlying infrastructure or architecture of the underlying infrastructure. All you're going to worry about is using it for your business goals and needs.
We've got a really great question coming in again from Island Fox here. Is cost optimization also built in doing this method for multi-region and having the code deployed to different regions? Or is there kind of extra steps to optimize that cost?
So, yeah, maybe I can answer that. So cost optimization is built in this architecture because what we are doing here is we are doing a multi-region, cross-region deployment using code pipeline, right? That itself is a cost-optimized, well-architected approach here, right? Rather than having one pipeline, which you can opinionatively have, one pipeline per region, we are using a single pipeline to deploy to multiple clusters. That itself is a cost-optimized approach that we are following here. It's a well-architected aspect. And also, we are not having code in multiple places, right? We are not having code in one region and multiplying the code in other region. We are not doing any of those things. All we are doing is having the code in a single repo as single source of truth, and we are doing that to deploy into multiple regions. So cost optimization is built in this architecture already.
Got it. Got it. And do you happen to know off the top of your head how pricing kind of works for? Is it cost per build or the underlying nodes, or kind of how does that actually work when you're using this suite of tooling?
So yeah, I mean, we can definitely reference the CodeBuild cost pages, but it's basically pay as you go model. You don't need to pay anything for an EC2 instance where you pay for an underlying cost, right? You don't need to pay any of those. It's pay as you go model. So you pay for the usage of storage, and you pay for the usage of the time you're using the build server, and so on and so forth. It's pay as you go model, as simple as that.
Awesome. Very cool. Now we're coming pretty close on our time here. Folks, if you have any other questions, be sure to drop them in chat. But very quickly, I actually do have another question here, Ila. Now, I know that there's a number of different things that I might deploy for managing these stacks. I've worked with customers where the RBAC stuff is good, the VPC subnets, but just like we're leveraging managed services for CI/CD, they may also want to leverage managed services for kind of higher level requirements, things like AI, ML, machine learning capabilities, or even simple storage, database tooling, that kind of thing. So let me quickly draw that out over here. Say people want to use something like S3 or SageMaker. I can think of a couple more here, but can we manage those managed services with this stack as well?
Yeah, absolutely. So I think what you're trying to talk about here is accessing those managed services from your Kubernetes resources, right? Like pods, correct?
Yes,
so
exactly.
What we have is something called IRSA, which is IAM roles for service accounts, right? So Kubernetes by itself has the capacity to give you projected tokens. So what we are doing here is we are using an IAM federation here. You can use an IAM federation where you can exchange the projected tokens from your Kubernetes cluster with short-term credentials from IAM using assuming an IAM role. So those short-term credentials will be part of your pod when you're using IRSA, which is IAM roles for service accounts. And with those temporary credentials, right, you can access these AWS services like S3, RDS, so on and so forth, for all your extra capabilities that you need for your processing of your application.
Perfect. Now, I know that very recently, I released a Lightboard video on containers from the couch about this, but EKS blueprints. That video, I was a little biased. I talked about EKS blueprints for Terraform, but I know that EKS blueprints also support CDK. So could I have used that instead of manually configuring some of these things?
Absolutely. You can use EKS blueprints, and EKS blueprints will be a de facto standard where you can bootstrap your clusters with all the required AWS add-ons and all the required third-party add-ons like Prometheus, GitOps, in all using the blueprints approach, right? You don't need to write your own VPCs, EKS scripts. You can use blueprints, and definitely it's going to be a lot of advantage in terms of bootstrapping your cluster. So yes, of course, Sai.
Awesome. Now we got a question here. As far as I know, true cross-region cluster is not possible. That's correct. You can't have an EKS cluster today with nodes in multiple regions. Now, I think that's potentially something that can be solved by using things like service mesh technologies and that kind of thing. For example, Istio has some pretty cool multi-cluster capabilities to enable you to manage the deployment and workloads across multiple clusters. But Ila, I think you'd agree, right? There's no true cross-region kind of, in that sense, cluster available in EKS?
No, it's not possible. True cross-region cluster, what we are doing here is cross-region deployment, but true cross-region cluster is not possible. Yes, you can use siloed clusters, but you're spot on, right? You can use Istio services like AppMesh, or you can to connect the clusters in terms of the approach. But yes, he's right. True cross-region cluster is not possible.
And yeah, at the end of the day, I think it's a matter of the latency between those nodes. I mean, Kubernetes really needs to assume that those nodes are co-located, and that's why we can do it within an availability zone, but not cross-region. But great question there.
Yep.
All right, we've got just 3 minutes remaining here. Ela, I'd love for you to kind of share how people can get in touch with you if they have any more questions about this. And folks, let me actually jump off frame here for a second if you want to take a screenshot of what we've drawn here as well. So I'll do that real quick.
Yep, and maybe I can talk about call for action in the meantime, right? So I think we are going to come up with a blog post on this approach in a couple of weeks. So I would highly recommend you guys to try this approach practically in your labs and try to get accustomed. And also above and beyond, you can also use services like Global Accelerator. If you're using if you're using an active pattern, like running 2 Kubernetes clusters in an active fashion, you can also use services like Global Accelerator. And of course, as Sai was pointing out, right, you can also use EKS blueprints as an option to bootstrap your clusters with all the recommended AWS add-ons and all the necessary AWS add-ons and also third-party add-ons. That's another call for action. And of course, reach out to our AWS containers community for any questions, comments, and thoughts, and drop your comments in this video when it comes to YouTube as well. And of course, you can reach out to me directly. I'm on Twitter with the tag I am Elashan. Thank you all.
Awesome. Thanks so much for joining me. Ela, I just posted your Twitter handle, excuse me, just posted your Twitter handle in the chat. The blog is going to be published very soon with actual code to be able to deploy this exact kind of multi-region deployment to Kubernetes using CDK. It's going to be on GitHub. It's going to be on GitHub as well as the containers blog. So be sure to catch it. Again, Ela, I want to thank you. Sorry, excuse me. Thank you so much for joining me here today. Folks, if you have any questions, be sure to reach out to myself or Ela. And thank you so much for joining us. And be sure to stay tuned for more live whiteboarding sessions like this in the future. You can subscribe to us on Containers from the Couch. It's a YouTube channel, Containers from the Couch. Be sure to catch us there for the next episode. Thanks so much, and join you next time.
Thank you, Sai. Thank you all.